All right, now we are talking. We are back on the good view over here, desktop view, right? Okay, so yeah, for the desktop uh, stream, let's wait for the people. Mm, Maybe I can just pop out the chat or not. Maybe I'll see it over here. Okay, so for the desktop, guys, I created this thing that I just solved or resolved on the mobile stream few minutes back. But I thought that if we are going to implement a new exercise, this one, this mini Redis tutorial, are you able to see it? This mini Redis tutorial, let me just do this, right? So I thought it should be done on the desktop stream so that everyone can uh, see through it. So basically this exercise, mini Redis that you can see over here is basically it's just more than this exercise, right? So we'll understand how to create CLI, how to use some of the variables crates in Rust like clap crate that help us to create a kind of a CLI application based on the commands, right? So we'll do that. We'll also see how to persist the data instead of just doing in memory, because we are just doing an in memory thing, right? So we need something to store the data. So we'll encounter all those errors that we can face. Okay. So yeah, we'll do this. But first on the desktop stream, last what I did was this the basic implementation of an hash map key value pair. I just did it on the mobile view, but I can do it for the desktop guys as well. But I have also, like I already did this on the stream, so let me just share the URL for that stream so that you can see how I did. It's for the container shareable link, and let me just paste it over here. Okay. Start Q&A, start a poll. Let me just post some Q&A over here. All right, so this thing has been like started, basically a Q&A. So how's the stream going? Any suggestions? All right, so I hope the stream is going well, and yeah, if you have any questions, feel free to come on chat. If you want to hang out, you can come on chat as well. And if you want to know or just talk, I mean, yeah, we're good here. Okay, so for the desktop guys, let's do this again. So what we did was we just understand how like arc and mutex is used to basically pass the data in between the threads, right? So the basic question over here is this one, where I want to just create a multi-thread word counter where I need to figure out how many times the word occurred, right? So the basic implementation was to use the hash map, just loop it over, split it into white spaces, and just increment the counter if I encounter any key. That is the basic thing that I did. But the thing over here is I have to just make it multi-threaded. So let me just quickly do it, because I already did it but somehow lost the changes. And also on the desktop stream last time we only did the basic one, right? So let me just do this thing and I'll explain it to you what I'm doing, right? Earlier, as you can see on the split string, I just check on the map, right? But the map is kind of unavailable right now because I have just wrapped it on in arc and mutex. Arc and mutex basically are the Rust primitives to work around with the thread safe implementation, right? So arc basically it increments the counter, the reference counted, and basically it is used to share the data, the ownership, used for the shared ownership in between the threads. And mutex, that is the mutual exclusion, it is used to prevent data races around any thing. So let me just implement it. So we already have the splitted text, right? So what I'll do, I'll say for item in, by the way, I already did this, I'm just doing it on the string. Okay, so over here what I can do, I can have the handles handle store, right? Why I'm doing this, because whenever we are going to spawn a thread, that thread is basically the handle, so we need to call join on that handle. So it's a required pattern right over here. Okay, so you can follow this thing. It is a basic pattern that whenever you start working with the you know uh, threads and all, you have to basically use this pattern. So arc and mutex are the powerful tool. Obviously if you are going to improve the efficiency, you have to use, instead of hash map you can use dash map, and instead of like log you can use rw log. But let's not that's the efficiency part. For now let's just simply make it. Okay, so here I will create a clone. Why I'm doing this, because on thread, when I spawn the thread, this takes the ownership, so everything moves inside that closure. Okay, so spawn takes a closure. So I'll, as you know that I have wrapped the mutex in the arc, so I need to make this a clone, right? So it takes a reference, so self dot store. Okay, so this is a clone. So over here I can say let handle equals thread, right? Spawn, let's spawn this, and it takes a closure and we have to move it. So I'll do this. So inside this we have to perform what thread does. Okay, so what thread does over here is it will just give me back the map, right? And that map can be taken by uh, the clone that we have. Dot I'll take the lock because it has the mutex, right? Now this returns a mutex guard. Okay, and it also returns an poison error, right? If the mutex guard is poisoned. So we need to make sure that we kind of handle the result over here. So I'll use the match statement. Okay, uh, I'll get the map over here, right? The mutex guard, and return this thing. And for the error I'll have the poison error over here, but I want to panic in this situation because if there is anything wrong with the threads I'll get to know. Okay, uh, I missed this thing, right? So and consider returning value. Okay, so instead of directly returning the string I'll return a result. By the way, this all has been explained. Why are we using result? Why are we just what is the purpose of box here? Why, what is the purpose of din here? Like, okay, and why this is used, box din error. Okay, so I have the handle over here and I have the map over here. Okay, So what I'm going to do is I'll have to make this mutable because I'll mutate this thing. And over here, what I can say, let count is equal to map dot entry. So this is the item, right? Or insert. This is how you check for the key if it's available. Okay. Then the default would be assigned to 0 if it's not available. If it's available, I will just increment the counter. Basically, they both we have to do it over here, right? So we have to check if the item exists and insert the default if not, and ultimately increase the count because we have to check the occurrence of word. And if we encounter any, that means the word has been occurred. So from 0 it becomes 1. If it's already there, it doesn't do anything and it will just increment 1 to it. Okay, and after this thing, what we have to do is, now that we also have to maintain the handles, right? So I'll say handle store dot push, and I'm doing this because we have to call join on the handles because we are spawning multiple threads over here, so we need to keep track of all the handles. So I'm pushing those things on the vector. Once this is done, what I'll do, I'll just say simply, loop on the handle store because I have to call join on them, right? So I'll simply say handle dot join, and because it is a result, so I have to handle the result as well. So we don't have to do anything over here, right? And on the error, I can just simply uh, panic from here. And handle dot join, and I have to make sure I match this. So just return the semicolon over here, otherwise it will be treated as the returned value. It says expected a string. Now here is very important thing that we have to do because it's a move. So basically what collect does is it already holding the reference of text, right? Because it will return the string slices, right? So I need to return the owned string over here, otherwise I will get an error, right? So for that I'll have to do this, and I'll use a map over here so that I can access all the elements and perform some operations to it. And this is a closure, and what I can do over here is as dot to string. Okay, so this problem is solved. It says this expected result string of them. Okay, try adding expression. Okay, yeah. So now that I have to return a result, so what I'll do, I'll just have to say this okay, because I have to return a result of string, right? So I'll say this, and over here I can return self dot store dot log because it's wrapped around a mutex guard, right? And it doesn't implement display. So I can simply say this. Okay, cannot borrow it because I have to make it mutable because I'm mutating the vector, right? This is done, and if I go on the main, I have already handled this thing because the read text is going to return a result, so I have to handle the result. I have the okay in this thing, right? And I'll get something like this if I run over here. I can see dog 1, fox 1, quick 1, lazy 1, brown 1, and the is 3, right? We need to do some improvement because we have lots and lots of this thing, right? It's a result, right? So we can access all those things that you can do. So yeah, this is it. The thing about here is it's quite inefficient because uh, I'm generating each thread. I'm generating thread for each of the text. That should not be the case ideally. for the larger file, we can always create a chunks, right? And then these chunks can be divided into the available threads. And how to get the available threads? The available threads can be like figured out by I'll say number of threads. If you want to get this threads, so you can do is thread dot available parallelism. So you can always do this. So available parallelism means it will check how many threads are there available that you can use, and once you have number of threads, you can divide the chunk of a file based on this thread. Okay, so let's say I have 12 chunks, right? And the available threads, the number of threads becomes 3. So what I can do, 12 divided by 3, so basically I'll have 4. So each thread will be assigned to 4 chunks. So this way we can efficiently create and assign chunks to the thread instead of just directly spawning a thread for each of the uh, text, right? That's what we are doing here. So yes, this was the exercise that we did. Now let's quickly go on to the next exercise. So what I'll do, I'll just create a new project over here. I'll say cargo new uh, Redis, CLI, right? Redis CLI, and I'll open nvim init. Okay, I'll open the main. Instead of hello world, I'll simply say Redis CLI. Okay, so let's start what we want to do. So first of all, let's go over here. Work through a mini Redis tutorial. I mean, it only said this, work through a mini Redis tutorial. So it means we have to figure out what all things that has been provided in Redis, right? So it's a basic Redis tutorial. Basically, Redis is a key value pair, right? A very highly efficient key value pair, that handles things very well. It uses caching and all. So we have to kind of create a mini Redis CLI. Now it's a CLI. You have to now see the example over here. It's not a continuous monitoring kind of CLI. It doesn't wait for the user to enter input and again. It's like a basic thing, like what we do over here, right? When I say git start, then or git init, it performs something and it exits, right? It doesn't run on the backend. So we will create something like this. For this, we'll understand few things. We'll take help of clap create so that we can create our sub commands, right? And probably to start this, what you can do, once you finish all those things, you can simply use cargo release on it. And once you do cargo release and go to the target directory, you can directly call this kind of thing, right? But for now, what we'll do, we'll create a basic implementation of it by using simply say cargo run, and we'll provide the parameters like double dash mini Redis CLI or set foo bar. Okay, so set foo bar means foo is the key, bar is the value, and when I get foo, I should get bar. The thing about this is we'll understand how this thing works, right? It should not be in memory because the program exits after this thing, and this remains, the value remains. Okay, and we don't have the database also, so we'll see how we can persist the data. Maybe we can create a JSON file, store it on our disk, and then load it on every program run, right? So let's do this. This will also set a basic foundation for you guys to create a URL shortener without having any database or backend, right? So yeah, let's do that. For that, let's understand few crates first. We'll understand clap crate. Okay, probably I can say crates dot io. Okay, and here you can check for the clap crate. Okay, clap crate is highly, it is like Very good, simple to use, efficient, full featured command line argument parser. Okay, so this helps to parse the command line, whatever you do. So let's go on the docs. Probably you can see the example, right? We're not going to just parse it over here. By the way, if you want to follow me on Git, let me just do this. Let me share the link of my Git, and you can see all the projects that I have worked on. Okay, let me just post it over here. Okay guys, let me know if you like this stream, and if you have any questions, feel free to come on chat. Probably I can, should I pop out chat, because I have to keep like continuously monitor this thing over here. By the way, a Q&A is going on, and I don't know how this works. I mean, should I get the immediate answer, or when I close the stream I'll get? So the question here is, how is the stream going, and any suggestion if it's going bad or you want to improve it, like that. Anyways, so this is the clap crate that we want to use, and if I want to use clap crate, what I can do is over here, if I just go and not clap, basically meaning Redis CL, Redis CLI. What I can do here is I can say cargo add clap, and I can just simply say features derived, right? So what does it do? By using this feature derive, you don't have to explicitly go on the toml file and use features derived thing. So let me show you. If I say if you see this, as you can see, as soon as I do this command cargo clap features derive, this gets added to here, features derive on the toml file. Without this, I would have simply be installed like this, clap with a version. Okay, with saying this feature derive, it means you don't have to kind of explicitly go on the toml file, right? Let's exit this thing. Over here, what we can do, let's go on the documentation, how to use this thing, right? So we have to kind of create modules. That's what we will do. And after creating modules, we can have a separate file called parser like this, where we will parse all those things, right? So we have all these things that are going to be on the argument, right? Count and all. Okay, and demo is the name, I think. So the name provides over here. We can create args, and then when I do parse args.parse, it will get parsed over here, right? Number of times to create an arg. Okay, but I want command and sub command kind of thing, right? Allow you to build a command instance. Yes, we are going to do this. Let's go over here. Author version, we can do like this. If you want, you can always have this thing, command new about. So we can do this. I'm just looking for where I have like kind of, I can just simply create, using the CLI, I should get all these things. So let's do for using lab with commands and sub commands and CLI and the rest. So this could be very helpful. So it says we have answer one for the main CLI stack, one trade for an enum. Okay. This is good. This is good. So we can have this command. Yes, absolutely. This is good. Amazing. This is what we need. We'll have a CLI struct that has all these things like verbose command. And here in the command, because see, we are going to make it a command based thing, right? So what I'll do is I'll call this thing like this, and when I do a set foo bar, so set is basically the command, right? I want to set the key value pair. So for this, we have to use a command config enum, as you can see here, right? So we'll do this. We'll have a verbose thing that I don't want to take it. We'll simply have a command over here, and this command will be an enum, because why we use enum? When we know that we have only the fixed set of things to perform, then we'll use enum. So we'll have two things like get, set, and delete, right? And these are the nested sub commands. So I hope you understand this thing, right? So let's do this. First of all, we have to create this parser and all, right? So we'll have to create a CLI struct, and here the command, and you have to derive a parser over here, and these things, okay, about and all, it gets shown in the help. So for that, let's create a thing called parser, right? And inside this I can create node.rs, and over here I can create parser.rs, and on the mode I can say of mode parser, and on the main file I can simply call it, right, mode parser. Okay, now let's go on the parser, and over here I can create this thing, right? So it says I have to create struct CLI over here, right? And inside this CLI, what I can say pub command, basically it's of type of command, right? And this command would be an enum, right? And this enum will have some things like get, set, probably delete as well, maybe del, right? uh, so get, set, del are the basic mini Redis features. Okay, so we are going to build that only. We also have TTL, right? A time to live parameter. This is provided to just adjust on the specific key how long it will be there, right? So it shows that, but again we'll only use get, set, and delete. And over here we have to define and derive a derivative method over here. So I'll say derive, what do we have to do, clap or parser, right? Parser, what's that? Use clap parser, yeah. So we have to do this. Cannot derive macro. Okay, and the command, in place of that I'll have to use command subcommand, right? So I can simply say command a derive helper, right? And inside this I have to pass the command. I have to call like this, as well. Expected argument instead of command. And command is basically so I have to define a subcommand over here as well. So I didn't like kind of memorize all those things, because it's available, right? It's not going anywhere. Cannot implement this. Okay. Mm-hmm. Command, subcommand. Uh, we haven't added subcommand, right? So it has to be imported as well. Uh, Cursor and subcommand, right? And these are the commands. So let's do this, right? And on the get and set, we have to do this thing. So the get will take a key value pair. So either we can have this thing like this, how it is like set key value and get key, right? So we can say get, and over here I can say key that is of type string, right? And on the set I can say a key string and a value string, right? And delete, basically it will be a key. Hope this makes sense. Expected comma. So I have defined the commands over here. I hope you understand it. The commands are fairly simple and very fixed, so that's why we used enum, right? I have get, set and delete, right? Get, set and delete, it should be camel case. Let's do that. Okay, get, set and delete. Few things that we have to do is provide some help and name to it. So I can say command name and this thing on the CLI, right? So I can say name and about, right? Redis, I can simply say Redis, right? And about would be a simple mini Redis tool, right? So like this, so it has commands and all, get, set, delete. So this is done. This is how it does, right? So we have defined a parser, and inside this we have created a CLI. This CLI basically it has commands, and these commands are get, set and delete, and you know why we choose enum, right? Now let's figure out how to just call those things on the main, right? So we have to just do CLI parse, and we have to just say, okay, if this is this input format, blah blah blah, command dot generate, blah blah blah, and command dot config, blah blah blah. Okay, So let's match these things. Okay, and yeah, so on the main over here, I can just do this. So let CLI equals CLI, create parser CLI, and I can call a parse on it, right? Clap parser. So let's print this thing. What do we get? And how do we call it? Doesn't implement debug. Let's store debug over here. Right? So we have to do something like this. Cargo run. Uh, Set bar. Let's see. Okay. Uh, Unexpected argument. We have to do this. Yeah. Now here's the thing. The thread debug is not implemented for commands. Okay, so let's go on the commands over here. So I have to implement debug over here as well. And you know why, right? Because I implemented debug for the struct, because the struct holds this enum. So basically we have to implement debug for the enum as well. You know, instead of like running again and again, you can simply uh, use a watcher over here, right? Like a Node.js watcher. So basically you can do it like that. And it says unrecognized command set. Okay, unrecognized command set. That has a key and a value. It can be tuple stub. Okay, get string or named stub or named arguments. To group related, maybe I can say uh, get set values. Get set values from the value listed the argument in match statement. Yes, we did this thing. Okay, get tuple variant positional argument. So instead of struct, I think we should do this tuple thing. Why? Because we can always say, okay, the first thing will be the key, right? Yeah, we can do that. And structure variant like this, key value. Doesn't make sense. Okay, we are good here. So this is working. It was not capital S, by the way. So you see what I get? I get a command enum. It has a set, and I see the key, foo, and bar. It automatically mapped it, right? Key to the foo and value to the bar as the first argument of this, right? So this is how clap helps us. So it basically matched it. When I pass set, it basically mapped the first argument with this key and value with the second, right? Now what we need to do is, if I go on the main file over here, I can just simply say commands, right? I need to match. So it's basically an enum. I have to match this as well. So cargo set foo bar. See, the set key is foo, value is bar. Okay. So I hope you understand this thing here. From here you understand how to use clap as a parser, right? How to use clap as a parser, and I'm just refilling my cup water. From here you understand how to use the clap parser and how to parse the arguments, right? And how to create subcommands. Now let me show you if I don't pass anything. So you see the clap is doing handling this automatically because we have initiated a subcommand kind of thing. So clap is basically creating a help thing out of here because we have commands enum, and whatever we have here you can see it, get, set, delete, right? And the usage is also there. Redis CLI, it is the name of our tool, right? Redis CLI and the command, okay, get, set and all. And if you want to this thing, you can just take help, right? You can also take the help of given subcommand. So you need to dig out the clap library if you want to like create a full-fledged tool, so that you know user can be, if you user want to take like kind of get help on the set, the usage of set and what all the details that you want to provide, you can just add something onto the enum, right? Clap provides all these. So yeah, now the main thing goes over here. Now that you have CLI and CLI command on it, so what you can do, you can just say match CLI dot command, right? And here you can match it because it's an enum, right? So you can match it over here. You can say set, or you can just simply say command parser, from parser, right? And you can directly say set. Maybe you should use it on the top, it's looking very ugly over here, right? Parser CLI, you can just simply say CLI and commands, right? So how to destructure the things, you can say this key value, right? And you can just print out over here. Again you have to kind of pattern match all the things, so you'll do a get as well, and you will do a delete as well, right? Okay, there is no body to it. All right, now I'm not getting any implement the exhaustive case over here. Why? This is the benefit of enum, because enum has fixed set of instructions or fixed sets if you want to do something, right? And the compiler knows it because you are pattern matching an enum, so it knows that you have already handled all those cases, and there is nothing going to be over here that you need an exhaustive case for. Everything is handled over here, right? If it was not an enum, then you should have to define this as well, an exhaustive case. If anything doesn't fall in this category, it falls in exhaustive case. Because it's an enum, you don't need it. So you can just use a question over here as well, that do we need to handle exhaustive case if we handle all the cases on the enum? So the answer is no. All right. Okay, let me check the analytics over here. We have one like. So guys, if you are really interested into Rust, then make sure you like this stream. And once this is done, I will do this again for the mobile viewers as well. Okay, now here what we have to do, on the commands, when you set the commands, right, you can always, and you have to handle the set command on the hash map, right, on the key value pair basically. Damn, the key value pair, right? And the same goes for the get and set. So how do we do this? We'll create another module for it. Okay, we'll create another module for it. Let me just share this URL in LinkedIn, or my ADHD keeps like kicking in between. I can see there are no like kind of users that can see this thing. Well, it's an interesting thing because we are learning a lot of things here. Basically, this is what I'm doing. Tell me live to create a mini Redis. I can say what you will learn. Number one, parsing command line terms. Number two, creating a CLI. Number three, creating a starting template for any CLI application. Number four, learn about lab crate. Number five, uh, persisting data on the in-memory apps. Number six, creating in-memory CLI applications. Here is the link. Let me just copy it, and I will simply say few tags over here. Rustlang, so okay, copy it, post it. Same goes for the Twitter. Oh my god, too much things over here. Damn, 43 things. You know this thing. Maybe okay. I can say okay. Now let's post this thing. Hopefully, we'll have some viewers. All right. So now let's do something. So here, now we have kind of did a pattern matching on this enum, right? This command enum. Now we have to handle all these things, right? And we are not going to do it here again, right? We can always have another folder for that, and we'll name it what should I name it? Redis. Yeah, let's do Redis. uh, I can always say mode, that's the requirement. Over here I can say redis.rs. On the mode I can say for mode redis, right? And on the main, why I always say moon to main, uh, and over here I'll just say mode redis, right? Let's go inside this thing. Now here we have to implement our key value pair and all the operations that we have to do to set that thing. So basically what we can do here is I'll create a struct, right? I'll call it Redis, and over there, just to maintain the things in memory, what I'll do, I'll say pub store. It will be a hash map, right? And obviously the key and pair will be string, right? Now do some implementation on it on the impl block. We can say new, right? It will return a self, and over here what I can say is I can simply return the Redis, and the store would be hash map new, right? Now here we will write all our implementation to get and set things, right? So first of all, let's implement set. What should it return? It should return. Now here we'll learn again few things. We'll learn how to implement basic, basically follow this pattern everywhere. This will like makes you more of a, once you do things hands-on, it will help you when you see the code, so that you remember what it's doing here. So I can say string over here, and while setting it I will simply use this thing. Now don't ask me why I'm doing this, because I have been told, like telling this on my every stream. Okay, now what does set do and what does set take? Because set is going to mutate this thing, so I'll have a mutable of self, right? And set will have a key, right? A key that is a string, and a value that is a string. Okay, now I have the key and a value, so what I'll do, I'll say simply say self dot store dot YouTube is not receiving enough video. Why is that? Oh my god, dropped frame. Okay, so self dot store dot how do we insert this? Okay, I'll insert this thing key. I'll just say key and value, right? And it expect this thing. Okay, uh, let me just see what it returns. Insert, it returns an option of a string. Either it returns an option of a string, So basically either it will have some or none. A way of checking whether an option has a value or not, that is called if let. These are called if let statements. Okay, so it's a one liner. If let sum, if there is a value, then it will be inside that item. Okay, so you can just print the item to check, you know item, and for now let's return this thing. Okay, expected a black. Oh, damn. What did I do? Um, okay, associated item new and sets are never used. Okay, I know. We'll call this from the main file, and we'll also see what do we get. Okay, let's go on the main file. Here we have to call this thing, right? uh, should I so we have Redis new, right? And I have to make it mutable because I have to mutate this thing, and I can say store dot set. I have to pass a key and a value. Result that must be used, so we are just passing the result from there, right? So we have to basically handle that thing as well, so it's a warning, right? Yeah, let's handle this thing. So result will either have an okay or an error, right? So if it's an error, we'll simply just do a print ln, error, and we'll also do a print ln over here as well, just to pass in the result. Let's do something over here as well. Let's call it press. Okay, so this has been handled over here. Let's not worry about this and this, so let's quickly jump over here and let's do this set foo bar. Okay, it's done, but the thing is we didn't able to, like, we're not able to see the map, right? So let's do this thing. Maybe we can just pass in. Okay, we didn't set the item, right? I'll say self dot store dot insert key and a value. Yeah. right? And then we need to show the map, right? So let's do this format. Okay, let's do a cargo run. Oh, no, no, no. Again, this is a wrong thing. I have to do this. See, the map is over here. Foo bar. So you see the map is set, right? The key value pair is set. So this means we are able to insert the basic key value pair on the map with this command cargo run set foo bar. Foo is as a key, as you can see. Foo is a key and its value is bar. Okay. Now let's implement get, right? So I'll say public function get because it will not mutate anything, so I'll just simply use self. I'll get a key over here, right? And it will again return a result of string and error. So here you can do something like this as well. Once you encounter any error, you can simply just return the error wrapped in err. Okay, but it's okay. How to get the item? So I'll say let value equals a self dot store dot get key value, and it will return an option of value, right? I don't want to do that. I can always use option of v, I mean the get, right? I need to pass in the key, so the key would be key, right? And I get the option. So here I need to just use a match over here, right? I would say match because either I will have some value, right, or I'll have none, right? If I have some I can say value, I'll return this thing onto the top, right? If I don't have anything, I'll simply just return an error that says uh, no key found, right? Expected tuple struct found. Let's see, this has to be this is this what it takes. Anyways, to return this thing, I'll simply say okay value, right? Expected this found result of no str. Okay. Uh, uh, I need to use this. This makes sense. Okay. I have to use this. Match arms have incompatible. This is supposed to be found of this and this. Oh my god, this doesn't have anything like that. Now the issue is match arms has incompatible type. Is found to be of type this and this. So instead of returning this thing, can we do something like through maybe this could just figure out this thing. The final option here is to just return this, because the first is like sum has returned a string, and it found this thing. Okay, expected string and found this thing, so probably you can just say format, and have the value over here. All right, so this is solved. Now this function just kind of fetches the value from the store and show it to the user. Now let's fix this thing over here, right? On the get I can say self no, say store get, and I'll pass in the key, right? Because it's a result, so I have to match that as well. Match, right? So probably I can just copy this thing. I'll just paste it over here. Super. Why it says stream's current bitrate is low? It shouldn't be low, man. It shouldn't be low. Why is it low? Why is it low, man? Phew. Okay, now let's see how it works. If I set foo bar, okay, this is set. Now if I get foo, no key found. Why is that? Why it doesn't like seem to be finding any key? Well, this we will figure out in next stream, because the bitrate is like, oh man, this is kind of very very ugly. Let me just show you what it looks like. I hope you can see this, like this thing over here. You see the bit rate over here is very low, right? 66% dropped frames. If I can just show you here, see the kbps that I'm getting: 479, 591. This thing over here, this thing. So it is like it's not letting me stream. So we'll continue this later. Okay, I hope you get it. Very important things we kind of will do on the next stream. We'll figure out how to make this thing you know memory safe. As you can see, currently I have set it the variable, but when I get it again, no key found. Why is that? These are the drawbacks of in-memory things. Okay, these are the drawbacks of in-memory things, and we are going to fix that. So I hope you kind of enjoyed this stream. It's very informative. We learn a lot of things over here, but my hardware is not supporting. I'm getting very, this time the frame rates are high, I guess, but again 60%, more than 60% frames are dropping. I don't know why this is happening. I think it is working now, right? So we should continue. Oh no, it's 0 kbps again. See this thing, 0 kbps. I don't know what's happening. So maybe we can start in few minutes, or maybe after some time, once I have a stable internet connection. So I hope you enjoyed this thing. If you have, make sure you like this stream and you subscribe to the channel for more such content. Ugly things are going here. If you have any questions, you can directly, check out my profile where you can see some LinkedIn links, right? Insta links, LinkedIn links, Twitter links. So you can directly DM me. And yeah, I'll see you in a bit. We'll continue this thing. This is very, crazy thing. We'll learn a basic tutorial basically, but we'll learn a lot from that. All right, then I'll see you. Bye bye. Bye, guys.